All right, so it says in a circle with a radius of 20 meters, the arc is intercepted by a central angle of 113 degrees. So let's label some of this stuff. So it's telling me that I have a central angle of 20 degrees, right? And then it's also telling me, no, wait, I got the numbers backwards. It's 113 degrees. Ugh, coffee hasn't kicked in yet. And my radius is equal to 20 meters. You think that's funny, huh? And then what's it asking me? To find the arc length. So I want to find the arc length. Okay. And then find the arc length to the nearest meter. So we're going to have to round to a whole number. All right. Well, we prefer this measure, and by the way, that's not to scale, is it? So let me, does that look like 113 degrees to you guys? No, 113 degrees is obtuse, so it's probably more like this, right? So I can do that. I can do the conversion of 113 degrees to radians. So remember, I want my degrees on the bottom, so the relationship is that 180 degrees is equal to pi. And remember, we want to leave pi in there. I think 113 is a prime number, which is funny. So this is going to be a little complicated, but it's okay. Maybe something will cancel out. So remember that theta in radians is equal to the arc length s all over the radius. So that means I'm going to have 113 pi over 180, right? That's my angle. If I just multiply this out, I'm not going to use a decimal or anything because this is what I was talking about. We want exact values. I don't know what the arc length is. That's what we're solving for, but this is 20 meters. So I need to get s by itself. Again, I'm just going to multiply by 20 on this side to undo the dividing by 20. And remember, whatever I do on one side of the equal sign, I have to do to the other. 20 meters divided by 20 meters reduces down to 1 over 1. So on the left-hand side, I'm just going to get s for the arc length. Yes?
Is that an s or a pi?
Well, the formula is the s, right?
But then what happened to the 113?
What happened to the 113? So what? Okay, so the angle is 113 degrees. But that's in degrees, and I want to convert it to radians. So to do that, I multiplied it by pi over 180 degrees. Essentially, the degrees cancel out, and now my measurement for theta is 113 pi over 180, which seems a lot. But they've rigged the problem up so that way when I multiply by 20, the 20 over 80 reduces, right? What's 20 divided by 20? 1. What is 180 divided by 20? 9. So this reduces down to 113 pi over 9. Now, because we're measuring a length and they said that we can round it to the nearest meter, I can plug this in the calculator. And so you're like, Mr. Adams, why didn't we just convert this thing to a, well, because we don't do that in math. At least in trig. So what we're going to do then is we're going to say 113. Did that answer your question? Yeah, you sure? Because you're, well, let's do this and then, I'll double check in a second. So divided by 9, and I need to round that to the nearest whole number. So 39.4 rounds to 39, right? Because the 4 is, you round down, right? So what we do when we round to the nearest whole number, remember this? You go one space over. If it's 5 or higher, you round up. If it's 4 or lower, you round down. So I use my little squiggly lines, and it's approximately 39. 39 what? Meters, right? We can't forget the meters. So that's the answer. All right. So did you have any questions? Does anybody have any questions? Did I lose anybody when I went through there? So remember, this thing prefers, when all this work that we're doing, the preference is that our central angle is in radians. So just to recap what they did, they gave us our central angle in degrees. They gave us the radius. The relationship between that central angle, the arc length, and the radius is this.